Have you ever thrown a paper airplane and it just landed 2 feet in front of you like that? Well, when you make a paper airplane, it has a lot of forces that are associated when you actually go to throw it. One of those being drag force. Myself, I have studied mechanical engineering at Iowa State University for 3 years now. I'm currently a junior, well, in the middle of my junior year. I've taken a lot of classes around fluid dynamics and done a lot of research and competitions where you have to calculate the drag force. So we're going to go ahead and talk about some of what actually is drag force, why it's important, where you can see it, and how we use drag force in engineering. So drag force is, in fluid dynamics, laid out as the drag force is defined as a resistance of a fluid that opposes the relative motion. So the fluid would be the wind or the air or water, not necessarily things on an everyday basis that you would think would be considered a fluid, but we do consider them the fluid here. So if this was the air has to move around the ball, and here the air has to move around the wing, and here the air has to move around the square. Well, the formula for creating a drag force has to do with this area here. So for a ball, it has more area, but it's kind of a medium amount of drag because the way it's able to go around the ball. And here, the same thing kind of exists. It might have more area this way, but the area is considered this way. So the square obviously has the highest amount of drag force because of the shape of it. Alright, some examples of drag force would be when you're parachuting. This is one example of where you want to maximize your drag force. So once the parachute goes out, there's more area and it kind of forces it to slow down and stop. Well, not necessarily stop until you get to the ground, but slow down. Vehicles, they use drag force in kind of the opposite manner. They want to minimize the drag so that way they're able to go faster or use less fuel. In airplanes, they kind of have both of them. It just kind of depends on where they're at in the air. So the formula for calculating drag force is the force of drag equals 1/2 rho times the velocity squared times the coefficient of drag times the area. So the coefficient of drag is widely known by now. It depends on a lot of things, but there's a lot of values out there for those already. The velocity is your speed, but more technical terms there. And then the fluid density is just the density of the fluid, that being the air or anything like that. And then the area is, of course, that frontal area there. So drag is important because we use it to slow the motion. You see it when you're parachuting and all of those things. But in drag racing, they use 2 different sides of drag force. The first one, they want to go fast, they want to win the race, they want to minimize that drag force that they have on their vehicle. The second one being they want to maximize the drag force to stop. So when the parachutes go out, there's more drag force because there's more area that the wind has to go around, which slows down the vehicle so that they don't crash into something. And then there's a lot of problems with drag too, like we talked about the fuel efficiency. When your car isn't fuel efficient, it's usually because there's a lot of drag force, a lot of wind coming out your car, and it's not perfectly designed so that that wind just flows over it. It kind of stops and then it uses more power, which takes more fuel and which uses more fuel. So then we get the lower fuel rates. We have, over the years in engineering, developed a lot of tools to overcome that drag force and been able to overcome it to where we are today, but there's still a lot to go into the future. So drag force is the resistance of a fluid that opposes the relative motion, and there are a lot of examples out there. Swimming, parachuting, vehicles, your everyday vehicle, when you're walking down the street, you have drag force coming at you, where it's often over time able to overcome that because of the power or the forces that we are able to go the other way. Engineers, we oftentimes have to take this into consideration in pretty much every problem that we do. Drag forces are just everywhere. They're not the worst thing to solve for, but sometimes it's kind of hard. When do you take that into consideration and things of that sort? And my works cited. Now I'm going to introduce my audience. Nate, you want to turn it?
Sure.
That's Dad. That's Mom. That's Nate. Thank you.